Hello Year 9, welcome to the second of our lessons on electrical circuits. Today we're going to look at the relationship between current, resistance and potential difference, following on from our work on electrical current and electrical charge last lesson. Okay, so we're going to look at what potential difference is. We're going to recap what current is. We're going to talk about resistance, and then we'll look at how they relate to each other. So let's discuss potential difference first of all. And I want you to imagine, okay, you have got two bowls in your hands with a string of Christmas beads between them. Those little beads that you hang on the Christmas tree. Okay, they're all joined up. The beads represent the electrons that are flowing around our circuit. Okay, the bowls that the beads are in represent either end of our battery that is in our circuit. Now, I want to also think about your ideas around gravitational potential energy. Now, gravitational potential energy, you will remember, relies on a few things, particularly the amount of gravity that is being placed on an object, how heavy that object is, but then also how far off the ground that object is as well, how far we have lifted that object off the ground. And we know that if an object is on the ground, it has no gravitational potential energy. The further it is off the ground, i.e. the higher up it is, the more gravitational potential energy it has. What we mean by that is that the bigger the difference between the ground and where the object is, the higher that gravitational potential energy. And the same thing is going to apply to our model here. So I'm going to show you this little video of me demonstrating this. Okay, and you can see that when the bowls are next to each other, there is no movement of electrons. Okay, they stay still. However, when I raise one of the bowls above the other one, those electrons start to flow. And in fact, the bigger the difference, the faster those electrons flow. I'm going to show you the other way around, because they can flow back the other way as well. Okay, so if there is a very small potential difference, the electrons do not move very fast. However, the bigger the potential difference, the bigger the difference in height, the quicker those electrons are moving. I'm going to play that one more time for you so you can see it. Okay, small potential difference, slow movement of electrons, no potential difference, no movement of electrons, therefore no flow of current. Big potential difference, fast current. Electrons are moving very, very quickly, and we get a much larger current. Okay. So what we're talking about here is the idea that a difference causes a change. Okay. So this is our kind of tagline: difference causes change. So a definition I'd like you to write down in your books is that potential difference is a measure of the electrical work that is done for every coulomb of charge that flows through a component. So what does that mean? Well, we know about work done from our work on energy. Electrical work done is simply some sort of effort that is being made in an electrical capacity. And we talked about coulombs of charge last lesson as being the rate of flow of electrical current. So potential difference is just a measure of the amount of work that is being done, the amount of energy that is being put through a component per coulomb of charge. And we measure it in volts. So as an example, there's a resistor here, and if a resistor has if we say that a resistor has a potential difference of 3 volts across it, that's how we quote it. What that means is that 3 joules of energy is being transferred to it for every 1 coulomb of charge that is going through it. Okay, 3 joules of energy for every 1 coulomb of charge. Okay, let's quickly recap about current from last lesson. So we recall that current is the flow of movement of an electrical charge, the movement of electrons. And we remember the size of the current will depend on how many charges are flowing. How does that then relate to resistance? So resistance, I want you to think about the word resistance and what does it mean to you. You may have some different ideas about about what the word resist means. In an electrical sense, what it means is to do with the prevention of current flowing through the circuit. So when electrons pass through, for example, a metal filament in a bulb, they have to push through lots of vibrating atoms. We know that metals have lots of vibrating atoms in there, closely packed together, vibrating around, okay? And then we have lots of little electrons nearby. And what happens is those electrons are trying to pass through the metal filament in the bulb. But because the atoms are vibrating, they resist the passage of the electrons through the bulb. So therefore, they prevent the movement of those electrons. They prevent the movement of current. Now, we can look at this in terms of the relationship between current, potential difference, and resistance. So this gentleman here called George Ohm, who was I believe, German scientist, physicist around the turn of the 18th century into the 19th century. And he came up with the idea of this relationship between these three factors that we've talked about. The current through, and what he quoted was something called his law, which states that the current through a resistor at a constant temperature is directly proportional to the potential difference across the resistor. So that means that if all things are equal, if the temperature of the resistor is kept the same, if it's maintained, nothing else changes, because remember, changes in temperature will change how a metal behaves. But if temperature is the same, the amount of current that goes through a resistor is directly proportional to the potential difference across it. And we call that Ohm's Law. So I'd like you to write down Ohm's Law. Okay, pause the video for a minute to give yourself a minute to do that. Okay, so we can visualize this relationship. Okay, so I am just going to show you what this looks like in a simulation. So here is our relationship. This is our potential difference V. Here's our current I, and this is our resistance R. Then we can alter just slightly the amount of voltage in our, I'm going to turn that volume off. We can change things and we can see what happens. So at the moment I've got 3 1.5 volt batteries in my circuit. Okay, and you can see this is my resistor here. You can see the electrons in there. The current that I've got flowing through my circuit is 9.3 milliamps. If I increase my voltage, let's see what happens. Okay, so let me say I add another battery, another cell. I've now got 6 volts. You can see I've increased my current. So my voltage has increased and my current has increased. If I go from, let's go back to 4. If I go from 4 down to 2, so we've got 12.3 milliamps, you can see I've got just about half. So I've got half the voltage and I've got just about half the current. Okay. If I go all the way up to 9 volts, I've got a current of 18.5 milliamps. And you can see that voltage and current are changing. Now let's see what happens when I increase the resistance or change the resistance. If I increase the resistance, you can see the amount of resistance that's in here. Resistance is increased. You can see that the I is coming down. My current is getting smaller. So if I increase resistance, my current decreases, okay? And if I decrease resistance, my current increases. So I want you to make a note of those two things, okay? If voltage increases, current increases, and vice versa. If resistance increases, current decreases, and vice versa. And one thing I want you to think about is why can we not alter the current? Why can we not manually change the current in this model? I can change the voltage, I can add more batteries, we'll take batteries away. I can change the resistance, I can put more resistance in, I can put a stronger resistor or a weaker resistor in. Why can I not alter the current? So I want you to think about that. Okay, so for you today, your independent practice work is to complete the worksheet of questions in the practice section on the Padlet for this lesson, and your teacher may ask you to upload those to an assignment on Teams. Okay, good luck with your work today, and I will see you for the next lesson.